Hi everyone, welcome back to Java with Hawa. As I said in the previous video, I'm practicing coding in a repub because I can't code. So I'm really working on the two-pointer pattern right now. And the question we'll be solving today is reverse words in a string. So this question seems pretty fun. How do I make this a bit less? Okay, that looks good. Okay, so this question tells us, it says given an input string as reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Return a string of the words in reverse order concatenated by a single space. Note that S may contain leading or trailing spaces or multiple spaces between two words. The returned string should only have a single space separating the words. Do not include any extra spaces. So they give us this example here, which is the sky is blue. So let's write that out. So we have the sky is blue. Okay, and note that it's possible to have leading spaces here, trailing white space, or multiple spaces in between. So really we're going to want to take care of this immediately. And the output is reversing the words of the string. So here you can see we'll have blue is sky the. So this output is blue is sky the. And the tricky part about this problem is notice that we're not reversing the letters in the individual words. Rather, we are just reversing whole words that are standalone. So that's what's going to be tricky, but we can get around that. So the way we're going to do this problem is, so if we have the sky is blue. Okay. Step one is we're going to work on clearing the leading and trailing white spaces as well as any multiple spaces in between. We can do this using the trim functionality in Java or also regex to replace all the spaces with a single space, all multiple spaces with a single space. So first we're going to say clean up the spaces in the string. Alright. So now on to the actual logic. Well, the first thing we can do is actually reverse this entire string, okay? So if we reverse the entire string, we'll have E, U, L, B, and then we'll have S, I, we'll have Y, K, S, and we'll have E, H, T, okay? Now this puts us in a good spot starting out because we actually have the words in the position that we want them. Like blue is first, right? Is second in our desired output. Sky is third, and the is fourth. The only problem here is what I just mentioned, which is we don't want the individual letters of the individual words in reverse order. We want them in their correct ordering. So this should be blue instead of yolp. And well, how we're going to do this is we're going to use a two-pointer approach. And the way it's going to work is we'll start our pointer here, one pointer here, and one pointer here. Okay? And what we're going to do is say, okay, I want this pointer here to keep inching forward until you get to a space, right? Right here. When you get to a space, so this pointer would now be here, okay? And what you're going to do is you're going to grab the index of this starting pointer, which we're going to leave stagnant, and this ending pointer, 1, 2, 3, 4, which in this case looks like it's on index 5. And you're going to say, hey, take the letters from index 0 to index 5 and reverse those. So you're going to reverse that word, and what's going to happen is from index 0 to 5, this will become blue. And now the way you know you're at the end of the word is if you hit a space in this case here, or if you're at the end of the string. So now once this becomes blue, we'll know that we've successfully reversed this part of our string, and we need to update the two pointers accordingly, right? So here we have this ending pointer, right? So what we're gonna do is say, hey, update this starting pointer now to be wherever the ending pointer is, right here, okay? Because you're about to start looking at a new word entirely. And once you do that, you can move the ending pointer to be at the start of the next word. And you're going to keep doing the same logic mechanism that we just said, which is inching this pointer forward until you come upon a space. And when you do, you're going to grab this index. So maybe it'll be like 6 because you might move it forward. And 8, and you're going to say, hey, I want whatever characters are from index 6 to index 8. I want you to sort those characters. Sorry, not sort them, reverse them. That way it can go back to its natural order. So once you do that, this word would become is, and you would then inch this top pointer to be wherever our ending pointer currently is, and you'd move this ending pointer forward by 1 so it can start looking at the new word. And hopefully that makes sense. And we're just gonna go until we hit the end of the string. So we'll need some kind of outer loop to indicate to us when we've hit the end of the string. And the way we can tell that is if our starting pointer, which is the top pointer here, whenever that becomes at the end, we'll know, okay, you're done with this string completely. Because it is possible for the ending string to hit a space or get to the end. But we'll know to stop when the starting string is at, let's say, the length of our string. Cool. So I think that's actually it for this problem. So once you're done with that, you'd have blue is sky and that would be the desired answer. And then here you can see they have an example of hello world that has leading and trailing spaces. So we're definitely going to want to make sure to take care of that. And you can see that in the return string in their output, they have hello world with just one space in between, and the leading and trailing spaces are trimmed. So for that operation, we're just going to use Java's built-in trim method. And for to take care of multiple spaces in between, we're going to use, I think regex matching or the replacing certain characters. So we're going to say something, we're going to use Java's replace all method. And we're going to say, hey, replace all these double spaces with a single space. Something like this is what I have in mind. Hopefully that made sense. I'm going to switch over to my laptop to code up this solution. And let me know if you have any questions with the actual logic of this. And maybe I can do runtime complexity right now. So in terms of the runtime, let's see. We're going to first trim the string. I'm not sure what's the runtime of that. Maybe it's just O of n. So traversing through the string to trim it. And also, we probably want to use some kind of string builder so that we are able to reverse these individual characters in an easier way. So, okay, I guess this is runtime 1, like trimming the string and cleaning it up, okay? And runtime 2 involves, we'll probably transform this string to a character array in Java since strings are immutable, and character array would allow us to perform our operations much more efficiently. So that's going to take O of n because really you're kind of iterating through the string in theory and copying over the characters to your character array. Our third runtime complexity is going to be, I guess, reversing that string. So that's going to take us, I guess, O of n really, if I'm thinking about it. Because if you're reversing a string, you may have a linear approach and you swap these characters, keep going here, keep going here. For the sake of this, I'm going to use string builder's reverse method, which I think is O of n. And also creating the string builder, I guess, should be O of n. I think I already mentioned that. I don't remember if I did or not. Yeah, and I think it looks like this runtime complexity is going to be O of n, and space complexity is going to be O of n, since we're going to be copying those characters over into our string builder object. So hopefully that makes sense, and let me know if you have any questions on this, and I'll see you guys in the coding portion. I'll probably stitch the videos together, or I'll have it in a separate video, but I think it makes sense to have them together. All right. Thanks for watching. Hi everyone, this is a continuation from the video I just did. So how the heck did I get rid of this thing? Okay. So reverse words in a string. Again, I'm going to stitch the videos together, so I'm not going to reread this. But really, we're trying to reverse individual words in a string and not the individual characters. So the sky is blue becomes blue is sky then. Okay, so continuing on from the iPad demo I just showed of the logic we'll take to approach this. So let's just write some pseudocode. So we'll say clean up. The first thing we're going to do, clean up leading spaces. We'll just say clean up all spaces. That includes leading spaces, trailing spaces, and also multiple spaces between two words. Okay. After that, what do we need to do? Thinking back to the logic, we wanted to create a string builder so we could quickly reverse our string. So let's do create string builder object um, to reverse string and reverse individual characters in the string. And we also want to, um, if we're gonna pass the string anywhere, let's create. Actually, let's put this. Let's actually do the string builder first, okay? So string builder first, and then we're gonna clean up all the spaces. So after the string builder, we'll say create a char array for efficiency. And that char array would represent our string. Since strings are immutable in Java, we want an efficient way to be able to perform operations on our string. So clean up all the spaces. Once that's done, we can assume. So we need to reverse our string. So here I already said that. So we create the string builder, reverse the string, create a char array for efficiency, clean up all spaces. And now once that's done, we can assume that we have a nice clean string. And now we want to start reversing those individual words back to their correct ordering, because you can assume after this step, the entire string is reversed. So you have EULB, SI, so on and so forth. And we don't want that because we know that the individual words should be in their correct order. So we're going to say use two-pointer approach to reverse strings back to their correct ordering. Okay, so let's move this. It's taking a lot of space. Okay, cool. So let's just get started here. Why is that happening? Okay, so how can we start this? We're gonna say string builder. We'll call it s2 equals new string builder, and we'll pass in. I don't know how the string builder documentation works. I think we just pass in our string s. I believe that's the right syntax. Okay. Now that we have, actually, let me make it a char array first. So I'll say char string array equals s dot to char array, right? That will convert it to a char and store it here. And then once that happened, we're gonna call some method, clean spaces, and let's pass in our string array. And hopefully this will return our string to us. So say string clean string equals this. And in here, we're gonna work on trimming our string. And once we've trimmed it, now we know that it's clean. We can pass it in here to be reversed and to be manipulated. Okay, so let's work on this clean spaces method. So it's just gonna be a private method. So we're gonna say private string clean spaces, and we're gonna pass in this char array. So we're gonna say char s, and in here we're gonna say s. Actually, what are we trying? What am I trying to do in here? So here we want to get rid of. Let me quickly search up getting rid of spaces. I'm really rusty, by the way. Excuse me. Hopefully the mic didn't catch that sneeze. It probably did. I'm very rusty, so I'm looking up documentation. Let's see. Okay, so with this char, I'm going to convert this back to a string. So let me just say array. So we'll make a new string. We'll pass that in. And 0, that's where we'll start with this new string because it's converting the character array to a string. And by the documentation, I'll pass in the length, how much to copy over, which should be the array dot length. Hopefully, yeah. And this is gonna clean those spaces up. Array dot length. So here, we're gonna say s dot replace all, or should I say s equals s dot replace all. So definitely need to do this. S equals s dot replace all. And I'm gonna pass in this pattern. That's gonna take care of those. Actually, this doesn't take care of the leading trailing spaces. Sorry, this is gonna take care of the double spaces. And let's just replace it with a single space. Okay, and once we do this replacement in our string, then we can say, hey, let's trim this. Let's trim the leading and trailing spaces. So this is gonna clean up all the spaces in our string. Okay, hope to God this is right. And yeah. I'm so rusty. This is so embarrassing. Okay, so now let's go back up to the code. So we say string clean string equals clean spaces. We pass in this char array version of our current string. We trim it, we clean it up, and we put it into this clean string. Now, when we're creating our string builder, we have string builder s2 equals new string builder. Let's pass in the clean string, and then let's reverse that using the string builder reverse method. Okay, so now what do we need to do next? So now I think we are in the perfect position to start using our two-pointer mechanism to iterate until we're at the end of the string and make sure to reverse those individual words. So we're gonna say int n, which is just the length, equals. I should give this a better descriptive name. Let's call this. Actually, s2 is fine. Or I'll say. What should I call this? This is the string we're gonna be working with, and I guess using to iterate. So or iterating through, I should say. So actually, let's just call it s2.length. I don't know. I don't have time to guess. So that's gonna be the length of our string. We're gonna say, and then we're gonna create two pointers, right? We're gonna have our starting pointer and we're gonna have our ending pointer, just like as I showed in the illustration. So in start and end both equal 0. And once that's done, we're gonna say, hey, I want to iterate until start is less than n. Okay. Excuse me. Okay, I want to iterate until start is less than n. And now what are we going to do? So we're starting our little iteration, right? Start and end are both here at the 0th position of our string. And we also want to make sure that we don't keep going until end is all the way past the end of the string. So we also need to check within here while end is less than end. But we add the extra check that we have not hit a space yet. Because whenever we hit a space or whenever we hit the end of the string by the end pointer, we know that indicates the end of a word, right? End of sky, end of blue, or end of the. So we add that extra check in this while loop, and we say keep incrementing the end pointer until you hit a space or until you're at the very end of the string. So we say while n is less than end, while n is less than n, this string s2 dot length, and let's call it len to be more descriptive. And also, you're not yet at a space. So while end is not at the end of the string, and end or the string that we're iterating through, so s2 char at the end does not equal this space. Okay, that means you're not at the end of a word yet. We're just gonna say n plus plus. So keep incrementing end until you hit a space. And now once you hit a space, what do we want to do? Well, once we hit a space, we know that end pointer has reached the end of a word, and the start pointer is at the beginning of that word, right? So we'd have something from like 0 to 5, and we'd want to reverse that. So instead of EHT, we'd have THE. So let's create a helper method to help us reverse those characters in place. So where can I put that? I'm going to put it here. Private void reverse. What is this method called? Reverse words. Okay, we'll just say reverse the string. Or reverse individual. That's too much. Let's just say reverse the string. And here we'll pass in our string builder s, and we need to pass in the bounds of what we want to reverse. So int start and int end. And this is going to be a typical string reversal. So we store the first character. So we have a while loop that goes while start and end have not yet crossed, and at each time we reverse those words. So we'll say while start is less than end. We'll say char temp equals s dot char at start, and then we need to say that sorry, and we need to say that now I want to set the char at start to the char at end. So it's like this. If this is T and this is H, you say, hey, store T in a temp, and then change T to E, and then change E to the T that's stored in our temp. So we use the string builder set char at method, and we say s dot set char at, and we pass in the index we want to set. So we'll say end, and we're gonna pass it in temp. So s dot set char at end. Wait. What am I doing? Sorry. S dot set char at the start, and we'll pass in end, or s dot char at end, I should say. I don't know how this method even works. String builder. I'm gonna look it up really quick. String builder set char at. String builder set char. Okay, yeah. So I just have to pass in the character. Okay, so string builder that set char at the start index. I want you to set the letter that's at the end, and then we call this again s dot set char at the end index, and I want you to set that to the temporary character that I have stored. And once you do that, you want to do a star plus plus and an end minus minus. So this is a typical reversing mechanism. And cool. So now, I'm tired. I have so much work to do. Okay. Now once that's done, we are going to go up here. And here we said that note that when end hits a space or the end of the character, the end of the string, that means that you've come upon the end of a word. You're going to want to reverse, so we'll call reverse string. We're going to want to pass in this string builder s2. We're going to pass in our start, and we're going to pass in our end. And actually, if end, since the way our reverse mechanism works is it directly takes the start and the end, it first reverses them, and then it increments and decrements. So the way our logic is set up here, end would be pointing to an empty space, and we don't want to switch an empty space with an actual character. So we need to make sure we actually swap from end minus one. So here, we can pass an end minus one, and it's going to start swapping from the actual end character rather than the actual space that end is currently pointing to. Okay, once we have that done, what should we do? So now you've successfully reversed this word back to its original form, and you may have some other words left to reverse to their original form. So we need to update the start to start. Start equals end. Actually, it should equal n plus 1. Okay, so it's going to equal the start of the word, and we also say end plus plus. That means, because right now end is on a space. So we want start to start here, and we want end to also start there. Okay? And once that's done, we should hope that we hopefully are done and that this string should properly reverse the words. I don't know where this while loop came from here. I don't know that I wrote that. So let's see if this works. Hopefully I don't have any bugs. Probably do. Oh, I did not change this to be len. Missing. Oh, okay. So I've reversed this string and I have not returned anything. So we need to return s2. Oh no, not s2. Where this function doesn't return a string builder, it returns a string. So I need to make sure to convert that string builder object back to a string. So let me actually give this a descriptive name that is result, because now that I'm returning it, I can see that I'm also confused. Results, results, results. Okay, so let's return results dot to string. And that should give us a string representation. Variable start might not have been initialized. Int start and end equals 0. I'm not sure if this is a different Java version. And missing a return statement. Oh, here. I was supposed to return S. Wow, I'm so rusty. And accept it. Submit. Have I done this problem before? Let's take a look. The last time I did this problem was September of 2021. Did I solve it in the same way? Let's see. Oh my god, I was such a diligent. Wow, this is such a different coding style than when I first did this problem. Oh my god, I did it in like 5 lines. What the hell? What the heck? Sorry, excuse my language. How the heck did I do this in 5 lines? So I said s equals s dot trim, and I did a null check, which is I should have done that. I'm getting lazy now. So I said if s equals null, return. Why would I return null? What was I? Wow, this is like when I first started coding. S equals s dot trim, trim trailing and leading zeros. String array equals s dot split. I split by space, I guess, into this array because I knew that strings were immutable. And then I said in left equals 0 and right equals array dot length minus 1. I swapped each string. I said string temp equals array at left plus plus. How the hell did this work? I'm not buying this. What? Array at right minus minus temp. And then I said string dot join space. Oh, I never actually reversed this string. That's why I didn't have to. How the hell did I solve this? So I never reversed the string. I fixed all the trailing leading spaces. And I said, well, left is less than or equal to right. String temp equals array at left. Oh, I'm going through. Oh, bro, this is hella smart. So here it looks like I'm actually storing the actual words, which is obvious. Sorry, I thought I was storing the characters in here, but I'm storing the actual words in this array. So I'll have something like the sky is blue as an array. I can't type in this thing, but I would have something like the sky is blue. Each are individual words in an array, and then I start from and I start from blue in the end. I swap those words, and in the end, since I already trimmed leading and trailing spaces, I return string, and the way I split it is by this, and I return string dot join. Dude, this is freaking way smarter than what I just did, and I thought I was much better at coding. Wow. I don't know. What do you think, people? I don't even think anyone will watch this. This video is for myself, but isn't it so weird to watch your coding style from like years ago? It's 2023 right now. What? How do I see? I'll show you guys. What date is it today? It's April 21st, 2023, and I solved this on September 9th, 2021. How was my coding starting out better than the coding I'm doing now? Anyway, I need to end this. It's way too long. Peace out. Let me know if you have any questions. Wow, I'm amazed. That's so cool how your brain really changes with the more knowledge you get, and sometimes for the better and sometimes for the worse. Stay safe, people.